I see the flying car industry as game-changing when it comes to not only future warfare, but future military operations, just as important, humanitarian relief operations, hurricane support, all the things that we do defense of the homeland. If you start thinking about these devices as nodes in a network, it fundamentally changes the game.
Agility Prime is a program with a vision of world impact. By partnering today with stakeholders across industries and agencies, we can set up the United States for this aerospace phenomenon. Potential outcomes are rewarding and transformative with both military and commercial applications.
I want to offer my congratulations to Dr. Roper and his team for achieving this revolutionary rapid contracting and prototyping method to bring industry and DoD together to develop this new exciting technology with both military and civilian applications. This technology will have great benefit to the needs that we have in Alaska and the Arctic, where conventional aircraft, vehicles, and vessels oftentimes can't operate.
Agility Prime is part of our Defense Department's long history of turning futuristic ideas into reality. I'm proud that the federal government is investing in revolutionary ideas. Agility Prime is leading the way.
This launch of Agility Prime is so exciting. This technology has the potential to make vertical flight more affordable and more widely available. And with the encouragement of the U.S. Air Force and the entire federal government, American companies employing American workers can gain a head start and win a fair share of this lucrative market. eVTOLs have the same agile, vertical takeoff and landing capability as helicopters, but are quieter and should cost much less to operate because of their electric motors.
We are becoming a trusted innovation partner in commercial tech. I could not be prouder of this initiative. I could not be prouder of this team. And I am excited to see how quickly we can go to help commercialize this market for our nation so that our warfighters have options they don't have today, and our nation has an economic advantage far into the future. Innovation is a battlefield, and Agility Prime is just one way we're going to win it.
Agility Prime seeks to ensure a global advantage in advanced logistics technology. Agility Prime can reduce the risk of adversary commercial dominance, resulting in military disadvantage. As the United States Air Force looks at generating combat power away from runways, those distributed logistics aircraft must be runway independent. This new transformative capability is a promising opportunity to conduct that mission in an affordable and a scalable manner.
Today we gather for Agility Prime to drive transportation innovation, lower barriers to entry, and expand our partnerships.
We see a time when automation technologies make the requirements on the pilot much less. And we see flying as being accessible to a much wider range of people.
So it's truly a great credit to Agility Prime. They can put on this virtual event with so many hometowns of the United States represented. You know, industrial base is not really about just what a country can make. More than that, it's about the people who dream up what to make. And then, of course, those people who make it.
Hey, good afternoon, everyone, and welcome back to this week's Agility Prime Weekly Webinar. I hope everyone's having a great Friday afternoon, and we're glad you could join us. Updates from Agility Prime side, we're coming to the end of our fiscal year here, so very busy with contracting actions, trying to get business out. I know we've been tracking the SCTR that you guys are all probably interested in, looking at the SBIR office, trying to get those awarded out next month as well. So very busy times for us. A couple of announcements for you guys. The SBIR open topic is being released next week, the 20.3 open topic SBIR. will be available on the 23rd of September for submission. So if you guys are looking to submit to that, I hope you guys are getting prepared. And if you guys want to reach out to us for help or any of that, feel free to. The webinar next week will be adjusted to Wednesday. We're having a special speakers on, being hosted by Mr. Frank Delsing of the airworthiness team here at Agility Prime. So they're going to be speaking on simplified vehicle operations. Really excited for that. That will be next Wednesday, not Friday at 2 p.m. So we have a great group of speakers today, really looking forward to it. So I'll just go through the list here. We have Harold Skinnaman, CEO of ANSU-R, UAV photo video communication via satellite. We have Dr. Ritin Gupta, research and development scientist at UTOPIACOMPRESSION for orbit enablers and accelerators. We have Alex Tates, the CEO and chief engineer of Fusion Flight, which is building a heavy fuel eVTOL. Michael LeCurie, CEO and co-founder of Aereo, looking at smart flight path automation. Mike Bartlett, founder and president of American Aerospace Engineering, who are building and designing a large VTOL tandem tilt-wing aircraft. And then finally, last but not least, Sean Wilson, the director of Air Force Innovation at American Data Solutions, looking at data management and technical data publications. So really looking forward to the webinar today. Thanks all for joining us, and we'll start off with Mr. Harold Skinnaman. Harold, over to you.
Thank you very much. Give me a second to share the presentation. Hello, everyone. My name is Harold. I'm the founder and the CEO of Untitled Technologies of Norway. And I'm going to talk about critical visual communications with a particular focus on UAVs. When I started the company, I wanted to solve fundamental challenges in digital communication related to bandwidth. I love photography. I did my master's with signal processing and image compression, did my PhD in joint source channel coding, and most of my professional life in satellite communications. So when I started my company, it was somehow logical to work with pictures and satellite communications. I named the company Answer because it's the root of the English word answer. It's a Viking rune, and it means communication, wisdom, and advice. And it's kind of cool because at that time, all the wisdom came from the gods. So it means you have the up and down links in order somehow. Our focus is basically in the intersection of these three domains: intelligence, surveillance, reconnaissance, and critical image communication over bandwidth limited radio and satellite networks. And typically then cameras that are born on airframes or floating or rolling on the land with high resolution imagery that you might need to have access to quickly. So part of the problem here is that we have an increasing bandwidth gap challenge. Not only has this always been a fundamental problem, but it's increasing. Over the last decade, the video resolution has increased from 240 by 320 pixels when iPhones came out with video and when YouTube started with videos, and until 8K video right now. That's 200 times increase in the resolution of the video, and bandwidth, and certainly critical bandwidth, has not kept up at all with that. And the tendency is that this is just keeping on increasing. I mean, I don't see that curve stopping. I don't see Samsung and Sony and Apple and Nikon and anyone stopping to make better sensors. In fact, we might be facing the biggest jump yet with quantum dot technologies, where in theory one should be able to pack 1 million times higher density sensors on the same surface area of a chip. So this probably will be a challenge that I think is worth solving also in the future. And I guess all of you guys know the bandwidth challenge, but it's recognized everywhere. You know, Cisco, bandwidth is a finite resource, Scientific American, bandwidth bottleneck is troubling the internet, New York Times, crummy connections are the biggest headache of the pandemic. And I guess most of us have been on telcos during this period of the last 6 months where someone says, let's turn off the video to save bandwidth. So bandwidth has become a quite common term. I talked to a UAV pilot a little while ago, and he was concerned for the time it took for getting his imagery, his photographs in this case, from him being a search part of the search and rescue to the rescue team. And he said they were always struggling with the bandwidth problem, and basically images could arrive too late. People were hypothermic, they could drown, they could freeze to death. Sometimes it was a matter of minutes, and he literally said too little bandwidth can kill if it delays my response time to the critical content. So I'd like to take you back to the birth of information theory. In 1948, Claude Shannon wrote a paper called The Mathematical Theory of Communication. The year after, his colleague Warren Weaver placed his theory into a little bit bigger perspective. And basically, I mentioned earlier that I was always working with signal processing, compression, and modem designs, etc. So as an engineer, we have been solving the problem of rate distortion. How do you get as much bandwidth as possible on the modem, and how do you compress the sources to as little as possible? But if you talk to an operations manager in the control center, for example, it probably would say something like, I don't care about bits and pixels. I need to see what I need to see in time for me to respond to it. So it's all about content that has effect on the operations. And this was actually written about, this 3-layer communication model, already in 1949. And I've seen papers that state we probably missed this, and we have been solving as engineers the wrong problem, and the decision makers need another solution in a way. So the 3 layers that were outlined already in 49 was like the one we all know: how precisely can symbols be transmitted, certain rate or limited bandwidth. But the next level is how precisely does these transferred symbols convey the desired meaning or the content that you need. And finally, of course, how precisely does that content affect the operations? So what we found is that by focusing bandwidth on content that really matters, we can save as much as 99% bandwidth. So this is much more than just regular compression. It's a new way of thinking about how to and what to communicate. So in a way, it's exemplified here. This image of this helicopter is taken by myself with a big Nikon camera. It's a very high precision sensor. But if we send it across the network in normal compressed version and you zoom in on a little detail like the gimbal, it'll be blurry. We all know this. But what if you can cherry pick exactly the parts of the images that you need? For example, by drawing on the received image and saying, I need that part, or letting computer vision AI just decide that part. Then it becomes a bit like CSI Enhanced. You know, you say, I need this specific part in full precision. And that's the way that our software basically works. And you can extend that concept to videos as well and other sensors. So here's an example. If I shoot a photograph with my either smartphone or with a drone camera or with whatever platform in high precision, I always tend to compromise and send a lower resolution version. Feel free to scan the QR codes, by the way, when this slide is up there. So then we're getting like a web quality or a little bit higher resolution image at the other side, but the original is still sitting at the camera. Well, we have then the possibility here to pull specific regions of interest from the receiver's side, who is the decision maker and the intelligence and analyst expertise. You can get exactly what you want without delaying also the non-essential parts. With video, we send this kind of storyboard that you see at the bottom left corner. That's a representation of the video clip that you may have captured. That kind of storyboard is roughly 1,000 times smaller than 1 minute of high definition video, which means you're getting that across for 0.1% of the cost, the bandwidth, the weight, and 1,000 times quicker. So it's getting you to a much more responsive situation. And then you can then pull exactly the detail that you may need to see. Let's see if this plays a little drone video here. So you can then, from the receiver side, choose what segment of the video you need, the resolution, the frame rate, and the quality of the video. And instead of being 150 megabytes or something like that, this video is just a few megabytes. So it gives you faster responsive information, basically. Okay, so that's photographs and video clips. What about video streaming? At the bottom left corner here, there's a small terminal from Cobham. It supports Inmarsat communication, and it's specifically made for UAVs. And it's quite recent, and it can do as much as, hold on, 200 kilobit per second. And the objective is to do video with this kind of data rate, which is roughly 5% of what you normally would need. Well, we have developed a video streaming solution that supports that device specifically for drones, and I'm sure it could be interesting for eVTOL and things as well. And you can get high definition across in roughly 200 kilobit per second. All the video is controlled from the receiver side, and it's easy to distribute that to multiple viewers. Again, everyone can be on double hub satellite links if you need to. It even has a mode for best effort data, because part of the problem with satellite terminals with low bandwidth is that there's usually a resource management system behind them that allocates capacity to the users, and the users have no control over how that is allocated unless you purchase the full bandwidth on your own. So then you're getting up to a variable bandwidth allocation scheme, but where you really want to use everything. So this software is also developed for that specific purpose. As you see from the video, this is a 4K video source that I'm streaming in HD. But if I choose to, I can pull regions of interest in 4K precision. Here's the HD. And then you may have seen that there's this mouse drawing a region of interest there and saying, I want to focus my bandwidth on this part of the image, but I want the full 4K resolution for that part. Now, while you're doing that, you can still record on board the drone or the platform the full 4K precision. And through this kind of storyboard that I just showed you on the previous slide, you can always access that if you need to. Sorry. So we have, based on what we're doing, we won something called the Critical App Challenge with Airbus Space and Defense. And they wanted to implement, or they have certified our software for this specific hybrid device, which is private mobile radio and 4G networks. It can also tether with satellite links. US Marines came across our software in January, and we did an exercise in Norway, north of the Arctic Circle, through Iridium Certus at the time, and we were streaming high definition around 120, 30 kilobit per second. And the Captain Des Hill, who was in charge of the event there, posted on LinkedIn, pretty amazing technology from Unser Technologies. One of the cool things is that we use this for disaster emergency management with the United Nations. And we have installed our servers at CERN in Geneva. So those of you who are a little bit nerdy will know that this is the place where Tim Berners-Lee invented the World Wide Web. And the world's first web domain is cern.ch, and we have our software running there. So I find that quite cool. But it's also quite nice that we're helping United Nations to save lives in disaster emergency management with this. And sorry for the typo in disaster management, by the way. For drones and UAVs, typically you would operate on the radio link. The radio link can be like from 10 to maybe 100 kilometers of range. The drones like the one you see at the bottom here have maybe 1,000 kilometers range. So having satellite communication basically unleashes the full operational range. And if you have an ISR target you need to survey, beyond that range, you can focus, your video and set stream video from a much larger operational range, maybe 100 times bigger operational range, if you're not limited by the radio link in these cases. So the UAV issues, limited by radio links, but satellites provide ubiquitous coverage. But there's an issue with cost and specifically capacity on satellite links, limited bandwidth for high precision photos and video. And then power, size, and weight are also issues typically. So even if you could have a bigger satellite terminal, many of these platforms are quite weight sensitive, and you basically don't want to build a bigger drone just to fly a bigger satellite dish and get a bigger airport and a much bigger budget. It might be better to have more cameras flying and use more effective or more efficient ways of transferring the data. And then, of course, if you compromise on compression quality, there's a real risk of missing critical content if it arrives to the decision makers in too low resolution. So with this specific UAV terminal that I showed you a picture of earlier, it has the capacity of only 200 kilobit per second, and that's the maximum rate. Typically, you would have less. And that's pretty low bandwidth for the desired service that you want with video, etc. And you will need typically high resolution photos and video. The next issue that could be a problem for many users is the cost. The bandwidth that you would need for normal operations basically could easily be more than $100,000 a year. And that's a high cost specifically for non-military sector, but I would like to think that military sector also would be a little bit cost aware. Another issue is due to the best effort operating mode, there are buffers inside the terminal that allocates a queue of traffic, and the resource management system is using this queue to allocate capacity to the terminals depending on how much you have to send. So this creates delays and buffers and jitter and many nice challenges for satellite communications and video streaming. So one of the scenarios we've been demonstrating with Inmarsat for special forces in Europe is this double hop video from drones to multiple vehicles and forward operating bases. And this is quite attractive, and it's working fine with the kind of solution where you have a server in the middle and low bandwidth. You don't have to be concerned that the receiver side might be on equally low bandwidth that the UAV is on, basically. So our software basically, I think, offers one of the most effective photo-video communication solutions with very high precision using least bandwidth. That's the main objective. It lets the users prioritize communication bandwidth on the specific parts that really matter, and can reduce the network bandwidth requirements by 99%. So it speeds up access to high precision relevant content. So I guess
Harold, I'm sorry to interrupt you. We're just going to have to go ahead and switch on to the next person here.
Yeah, it's finished.
Oh, okay, great. Yeah, I know there's a few questions for you in the Q&A. If you want to go ahead and just type your answers there for folks. Definitely a few people with more in-depth questions for you. So thanks for coming on, Harold. Appreciate it.
Yeah, thank you very much. Thanks for having me.
Yeah, and so now we're going to switch over to Mr. Matt Villarreal, founder and CEO of Infinite Composite Technologies. Matt, over to you.
Thank you. Just get my screen share going here. Are you guys seeing my slide, or is it presenter view on that side?
Yeah, Matt, it's a little bit small.
Sorry, guys.
There we go. That looks good.
Any better?
Yeah, that's good.
All right. Over the past 50 years, the cost of sending cargo into space has been driven down by more than 50% due to the introduction of new launch vehicles built by startup companies, led by billionaire tech entrepreneurs with grand visions of exploring the universe. Major innovations have been made around engine technologies to increase how much cargo weight can be lifted into orbit, but we've made little progress around reducing the heaviest part of almost any spacecraft or launch vehicle, the fuel storage tanks. Even on lunar landers and satellites, fuel tanks can make up more than 50% of a vehicle's empty weight. These highly engineered tanks often serve as many vehicles' primary structures. There can be more than 100 tanks on board per flight. Even state-of-the-art tanks typically require a metal liner to contain the gas. These liners are a major driver of mass and cost, and their lead times can extend expected mission timelines from months to years. My name is Matt Villarreal, and I'm the founder and CEO of Infinite Composites Technologies. Along with my co-founder, Michael Tate, our team has spent the past 9 years working to achieve what has been the pressure vessel industry's holy grail for decades. That's why we introduced the Infinite Composite Pressure Vessel, the world's first linerless composite pressure vessel for high pressure gas storage. Our Infinite Composite Pressure Vessel technology leverages nanoscale materials and advanced processes to eliminate the need for a separate metal liner and provide the optimal solution for storing compressed and cryogenic fluids. This enables up to 40% lower mass, up to 50% lower cost, and 80% shorter lead time versus state-of-the-art tanks. We've been awarded 5 patents and have put our technology to the test in extreme conditions to prove their safety, even in the harshest environments. Since our founding, we've delivered more than $3 million in contracts to customers like NASA, the Air Force, the Army, and private space companies. Already in 2020, we've delivered 11 tanks to 2 different NASA centers and a private launch company, and have secured contracts to deliver 20 more by the year's end, which is a 500% increase from 2019. This includes initial hardware for a 300 satellite constellation, multiple space launch vehicles, and an electric passenger aircraft. These projects alone will grow to 780 tanks and generate $11 million by 2022. Our technology is a game changer in a broad range of applications, underwater, on the ground, in the air, and beyond. And while space is our beachhead market, the overall demand for the $58 billion global pressure vessel market is booming. And with the emergence of the hydrogen economy, the industry is poised for exponential growth over the next 5 years. I'd love to talk to you about how our projects can keep your projects underweight, under budget, and on schedule. Thank you.
Hey, so yeah, thanks, Matt. Just a couple of questions. I think as it applies to our Agility Prime community, the most interesting topic is hydrogen. So
right.
Just a little bit on your tanks. What kind of pressures are you rated to, and what kind of mass fractions are you getting to for hydrogen storage?
Yeah, so on the mass fractions, with the not going to any exotic fibers, we're able to get roughly 10% storage efficiency. The tanks that we're building for the electric aircraft are 5,000 PSI hydrogen tanks, but we've built tanks that go up to 14,000 PSI. And that's even after 20 years of simulated useful life, so 20,000 pressure cycles. So the upper limit on pressure is not necessarily a limiting factor, but the tanks we're building right now are 5,000 PSI for high pressure hydrogen. And then we've also got an MOU with the Air Force Research Lab for liquid hydrogen tanks for an aircraft program that's being developed by them.
Yeah, very interesting. And then I guess the main difference here is that you guys aren't using the metal liner. Are you seeing comparable leakage rates or seepage?
Yeah, so the permeation rates on our tanks are similar to Type 4, which is a plastic line composite wrapped. That's the data on that's a little bit dated, so it's about 4 years old, but we're about to do another permeation test on the hydrogen tanks that we're building for this aircraft program. So we believe that we can get nearly on parity with the metal line tanks once we get that new data.
Yeah, no, for sure, very interesting. And then is there any volume limitations, either small or large, for you guys?
Right now, with our current equipment, the largest tank we can make is 30 inches in diameter by 12 feet long. With about $1 million of CapEx, we can scale that up to 60-inch diameter by 50 feet long. But no, we haven't seen a theoretical limit on how large we can build the tanks using this technology yet.
Very interesting. And then as far as manufacturing timeline, is it comparable to others? I assume you're using machine wrapping techniques similar to other folks.
Yeah, we are, but because we don't have to produce a secondary liner, especially on the metal liners, those can be significantly longer lead times versus ours. So we can save a significant time and cost because we don't have that liner to deal with. So it's primarily we build a form and then we wrap the carbon fiber on it and then we extract the form, and that's basically what the process looks like. So no secondary processes for manufacturing a liner.
Very cool. And then just from a supply chain perspective, are you guys getting your fibers in-house? Do you manufacture them, or US supply, or where do you guys get those from?
Yeah, there's a variety of different suppliers. Sometimes it's specified by the customer, but a lot of the fibers we're using are your typical like Toray or Mitsubishi carbon fibers. Sometimes they're like industrial grade. Sometimes customers request very exotic high modulus fibers, but we can use almost any fibers that we've gotten our hands on to manufacture these things. So pretty flexible in that area. Most of our materials technology is in the custom formulated resins that we use for bonding the carbon fiber.
Yeah, very interesting. And then just a question from the audience here. So James Nelson is just asking for potential uses in healthcare, i.e. oxygen tanks in hospitals or EMTs, particularly helicopter life flight, because he's saying that these E-type or H-type cylinders are typically solid stainless steel.
Yeah, so we're also talking to some folks from the Air Force about some of their oxygen breathing air tanks. We've done some testing with gaseous and liquid oxygen. We haven't done the full battery of tests on those, but we're working with NASA White Sands to do a full oxygen hazard analysis. But yeah, there are a lot of potential applications in medical for storing oxygen and breathing air, and we are pursuing some of those.
Yeah, well, thank you. That's super interesting. I think a lot of folks working in the hydrogen space could benefit from it. So thanks for coming on. Appreciate you.
Yeah, thank you.
So now we're going to switch over to Dr. Ritin Gupta from Utopia Compression, speaking as an orb enabler and accelerator. Doctor, over to you.
Thanks, Sterling. First question, can you hear me all right?
Yeah, we got you, sir.
Okay, I'm just going to share my screen right now. Okay, thanks everybody for having me. I'm going to be talking about passive ranging for detect and avoid. And just a quick background about our company, Utopia Compression. We're a small business in Los Angeles, been around since 2002. We are essentially an R&D and engineering company. We have a long history of working with the US government, primarily the DoD. Our subject matter expertise is in many areas. Computer vision, machine learning, and unmanned systems are some of the main areas that we work in. Our flagship products are in the computer vision field. The focus of this talk today is going to be some of our UAS applications, and really it's not only UAS, but manned aircraft as well. And marine applications as well, such as that product shown to the bottom right, but that'll be a topic for another day. So I'll start with detect and avoid. This is important for kind of the future of the aviation industry, especially with unmanned aircraft, but also with manned. And probably a lot of people online here are somewhat familiar with it, but I will go over it anyway. Detect and avoid can be considered kind of the last layer in an automated collision avoidance system. And as the name suggests, we need to detect intruders using sensors. Intruder is really another aircraft that represents a collision hazard, someone that's flying close to you. And we need to detect it and then execute an avoidance maneuver. So for UAS, for unmanned aircraft, it's quite obvious why this is important. This is basically the unmanned equivalent of a pilot's ability to see and avoid an intruder. So in a layered collision avoidance system, you have many factors that prevent a collision. You have cooperative systems such as ADS-B, you have radars and things like that. These are all very important. But at the very end, that this last layer in a last emergency is a pilot's ability to see another aircraft out there and to maneuver so he or she can avoid that threat. So, and obviously with unmanned aircraft, you don't have that, especially with beyond visual line of sight operations. And that's why detect and avoid is important. So important, in fact, that it's actually mandated by the FAA for integration of UAVs or UAS into the national airspace system. But like I said before, and like I'll be talking about, where we come in, what our technology does is really the detect part, the sensing part of this kind of system, being able to find these intruding aircraft and recognize the threat. And that's important even for flying cars, for what's envisioned with orbs, for Agility Prime, because it offers the pilot extra situational awareness. Okay, so specifically what we do is passive ranging, and I'm going to talk about why that is important. So there's many ways to detect an intruder. There's cooperative ways such as ADS-B or ACAS-XU, but obviously not all intruders are cooperative, and we need to be able to handle any intruder. So non-cooperative ways involves using sensors such as radar and optical. Our forte and our product uses optical sensors. And why are they important? Well, optical sensors are basically cameras. They're small, much cheaper than radars. They're low power and they're passive. That means they're non-RF emitting. That's very important because you don't have to worry about compliance issues with RF. Obviously, in a military setting, passive is important because you might want to be covert, but regardless, there's many advantages of being passive. Okay, but there's issues with optical. So anybody that's aware of the idea of tracking and estimation of targets knows that with an optical system you can't estimate the range because a camera image is just a 2D projection of the 3D world. So the ways to get around that are if you have multiple cameras. Stereo camera systems allow you to kind of do what human eyes do, and they can be used to estimate range. Or you can fly in kind of a meandering path, and if you get multiple views of the target or of the intruder, then that can be used to estimate range. But all of these are not advantageous. First of all, using multiple cameras is not really an option with a camera because you can't space them apart enough that it would enable you to estimate the range, the depth of this intruder. And flying in a meandering path is not a good idea either. That's kind of bad airmanship, and it's an inefficient flight as well. So what our technology, which I'll be talking about, called PCAS, does is it really solves that problem. It allows you to fly just in a straight line using a single camera, and it's low cost and lightweight and everything, and gives you a full 3D estimate of the intruder without any of these special maneuvers, so to speak. Just want to make sure. Yeah. Okay, so PCAS is basically, as I talked about, it's a low-cost system. It does passive ranging for detect and avoid, but also for situational awareness for piloted aircraft. So up there on the upper right is just a kind of an image of the or graphic of the pipeline. Basically, you have a detector that takes a camera image using basically computer techniques to find intruders out there. We also use a low-cost GPS INS system, and that enables our tracker to basically keep track of the intruders. And then it goes through our real breakthrough was with the range estimator, and as I mentioned, that takes just this 2D image and the INS information and estimates the range and the full 3D state of that intruder. So we've been working on this for a number of years. The funding has come primarily from the US Air Force and DARPA programs. It's been extensively flight tested through probably five or so flight test events over the years. And on the bottom right, that just shows an example of how our basically ranging filter estimates converges to the true range. Several applications have been I've listed there. Obviously, the flying cars and orbs is the focus here, but also with small UAVs for package delivery. Search and rescue drones is an ideal application because you might have a drone that has an optical sensor that's looking down at the ground for survivors, or for other, perhaps a law enforcement application where you want to get imagery of the ground. And in those areas, you're flying in relatively clear skies where optical sensors are ideal anyway. And so in that case, optical sensors would be ideal for detect and avoid as well. And many more. Just one other one that I forgot to write there is for military applications for surveillance and reconnaissance. And we actually have interest from the Air National Guard for the MQ-9 program as well for a long distance version of this, where obviously in such a scenario, being passive is of paramount importance, and these aircrafts have high power optical sensors on pods such as the MTSB pod, and we've been in discussion and actually have interest and in MOU. So we're trying to get AFWERX interest in carrying out that program, and we feel confident that something will happen there as well. Lastly, the past, present, and future. So the past up till now is basically we've had a lot of funding from the Air Force and DARPA the initial motivation came about for a passive ranging solution for the Global Hawk. So far, our systems have been single camera 40-degree field of view systems. Currently, we are collaborating with New Mexico State University and their UAS test site, and we have funding from the FAA to demonstrate an expanded field of view 220-degree system. We have 4 test events, of which we've already carried out 1 over the coming year. So we're excited to push this further. And obviously the future will involve commercialization of this product and entering the market. As I said, it's very important for UASs because this is an FAA mandated technology, but participation in Agility Prime would be a great desire of ours, and we're looking forward to working with anybody that has interest, as I said, in detect and avoid, or has any other interest in this technology. We're happy to work with anybody and answer questions. And I think I'm at the end there.
Yeah, for sure. Thanks, Dr. Gupta. If you could, I don't know if you have a slide with your email and whatnot on it, but if you could just throw that up so people could contact you if that works for you, or just give your email.
Is it all right if I just put it in the chat?
Yeah, that works perfect. I have a few questions from the audience as well. So
sure.
Robert Love was asking, what resolution camera were you using for the convergence estimate there?
Yeah, that one was 4 megapixel. In the new system that we're planning to use, that will use a network of 3 cameras, 8 megapixels each. So we have a novel way of actually splitting that in an embedded processor and doing the same kind of processing.
Yeah, sure. And then Bill was asking, does PCAS provide 3D images while hovering? And I guess also one question I had was, how fast is your host vehicle allowed to travel, I guess? What are you seeing in terms of limits on performance there?
Sure. First question is actually a good question, and we actually require the ownership to be moving. Has to be moving. Although we have other ways where we can still get good information, detect and track intruders and things like that with a hovering ownership. But for the range estimate, you have to be moving. And sorry, Sterling, the second question I just asked it and I already forgot.
Yeah, it was more about what limit of speed for the host vehicle.
Yeah, so in those tests, we're looking at about 30 meters per second. It was a Group 3 UAV, but we've done feasibility studies, like I said, for the application for the MQ-9, where it would be a lot faster. I don't recall quite the speed there, but we're looking at maybe hundreds of meters per second. And everything can be handled. It's just tuning of parameters, basically, for the ranging filter.
Sure. Okay. And then just a little bit on how have you guys tested any in heavy clouds, rain, or fog? I assume that's a big problem for you guys.
Yeah, that's an issue. So obviously, this requires clear skies. We can detect in clouds, but basically, if a camera cannot see that intruder, this system is not going to see it as well. So this could be part of a bigger system, a multi-sensor system, or like I said, if you have applications such as search and rescue or law enforcement type of applications where you're flying in clear skies anyway, this is ideal for that.
Perfect. Well, thank you, Dr. Gupta. Really appreciate you coming on. Informative as always. And like I said, I think a few people wanting to ask you a few more questions. So if you just put your email in.
You bet. I just put it in the chat, and sorry I didn't put it on the slides, but it's basically reten@utopiacompression.com. It's in the chat.
Perfect. Thank you, sir. And so now we're going to switch over to Mr. Alex Tates, the CEO and Chief Engineer of Fusion Flight. Alex, over to you.
Yes. Hi. Let me just go ahead and share screen. Okay. Everybody can see this?
Yeah, we got you, sir.
Okay, so I am Alex Tates. I'm CEO and Chief Engineer of Fusion Flight. We've been developing a VTOL jet-powered vehicle since 2016. My company is a startup, very small. I basically do everything at the company. I still work out of my garage at the house, so that's kind of like the background. So I'll start by covering our single-person transport, which you can see on this first slide. This is a concept based on our half-scale model. As you can see, it is the most compact type of orb that you could possibly have for a single person. It is powered by 4 microturbine jet engines, each outputting 120 pounds of thrust at full throttle. Each engine is equipped with a proprietary thrust vectoring system that allows vertical takeoff and landing operation, hovering, agile maneuvering, as well as high-speed downrange travel. State-of-the-art avionics allows autonomous mission execution. That means that the pilot hands are free. He's able to use and do anything with his hands as he seems fit. A vehicle, as you see here, would have anywhere between a 20 to a 30-gallon tank. That's, again, depending on the application. So that is the first application, would be this high-speed single-person transport. In the same configuration, we could build emergency medical evacuation, a medevac. As I call it, a flying stretcher. It's very compact, so it can land in very tough to reach places that are normally inaccessible by helicopter, and then evacuate the patient to a nearby base or hospital at very high speeds. Again, for this non-aerodynamic version, you're looking at something like 250 miles an hour. And of course, it's based on the same platform as the single person transport. So one technology can kind of give you both of these vehicles at once. Now, I just want to explain that this is not an electric VTOL concept. This is a jet powered concept. It's fueled by heavy fuel, diesel, Jet A, kerosene. And it has a lot of advantages over eVTOL, which is commonly found in the ecosystem today. And there's a number of items why it's advantageous. Of course, it refuels in minutes. You don't have to swap batteries or wait hours to recharge. Heavy fuel compatible. Out in the war zone on the battlefield, diesel, Jet A are readily available. It is long range. Again, the vehicle that I showed you there could travel up to 60 miles in one way. Obviously high speed. Turbine jet engines are not limited to speed as much as propellers. So you could potentially build something that travels close to the speed of sound. It's highly compact and does not weigh a lot. So this small single person transport unfueled weighs roughly about as much as a single person, maybe 130 pounds. So easily carried by 2 people, fits on the back of transport such as a Humvee. Of course, you got your high altitude operation, very high altitude. Again, rotors, propellers cannot reach and operate well at the same altitudes as turbine jet engines can. You get weather resilience since you're using thrust vectoring and the engines are internal to the vehicle, no moving propellers, no external airfoils. And it is an affordable system because it uses entirely off-the-shelf components. We have been building a half-scale proof of technology. It's called the AB5. We had a successful test flight in October of 2019. It was a 2-minute hover at about an altitude of 20 feet or so. As you can see in this picture here, this is the AB5 prototype, which we have flown. It has a 5-gallon diesel tank. It's powered by 4 40-pound microturbine engines. And of course, it has our proprietary thrust vectoring system. Currently in development is the AB6. As you can see here, it is the same half-scale model, except that I have refined significantly many of the technologies to make it a more reliable vehicle. So that includes software, thermal management, fuel systems, and pretty much everything. I'm ready to go into qualification flight testing for this vehicle within the next several months. Just a brief overview of where we were and where we're going. Received an original seed investment of $50,000 in 2016 to build this half-scale version. Achieved stable hover in 2019. Require about $5 to $20 million investment to finish R&D, scale up the version, and transit to production. Of course, that includes establishing a facility and everything. As I mentioned earlier, at the moment, I'm doing everything out of my garage. And finally, we will have, if everything goes to plan, the AB7 orb available for purchase at, I believe, an affordable $400,000 per system, hopefully from year 2023 and onwards. For more information about the vehicle and detailed description as well as specifications, you can go to our website. Also, there's a YouTube link here for the flight video. of the AB5 jet quad. And if anybody has any questions, I'll be more than happy to answer them.
Yeah, for sure, Alex, that's great. Interesting to see you guys are getting ready to start doing more certification flights. Really exciting stuff there. So I have a couple of questions from the audience here. Bill Kleinbacher is asking about range, I guess, just a little bit on the performance, range, payload, speed kind of things.
Yes, sure. So the payload for this AB7 would be a 200-pound payload. That's what we're shooting for. It's basically, we believe it's a standard weight for a human plus some gear, not a lot, obviously. Expect the range to be about 60 miles one way on a single 25 gallon tank. That flight will take about 15 minutes going at approximately 250 miles an hour.
Yeah, perfect. There's an anonymous attendee who just wanted to give you some motivation that Steve Jobs also started in his garage. So,
okay, thank you. Yeah.
Yeah, just a little bit on the acoustic signature. I guess you've flown a small scale one. I assume it's pretty loud with the turbines, but.
Yeah, so again, turbines, a common misconception that they are much louder than eVTOL, but keep in mind, this is a very high frequency noise, so it dissipates very quickly with distance. So if you're up close, 1-2 feet away, it's very loud. Once you get past 20-30 feet, it's not even that loud anymore. And keep in mind, any sort of propeller-based vehicle, whether electrical or not, the propellers themselves generate quite a lot of noise. So I think it's worth to explore to really understand, are jet engines much louder than very large propeller blades spinning at a high RPM? And on top of that, I would like to add that we are exploring noise suppression systems. As a matter of fact, the AB6 prototype has special designed intakes and the body that is able to suppress a lot of the noise from the turbines. And I have 2 little kids at home doing tests in my backyard. They're sleeping just fine through the tests, so I don't think this is going to be an issue.
Yeah, for sure. And then I guess just Gregory was asking, why no wings on it, kind of for a transition to horizontal flight? Did you explore having any aerodynamic surfaces? Or?
Absolutely, and you can head on right to my website. We have explored it. As a matter of fact, Boeing and NASA did great study on the blended wing body design, and that is really the optimal design for us because it has a very large internal volume, so we can fit our platform with the turbines in there, and we can also use the whole body as a lifting surface. So what you see here, the AB7 Orb is really supposed to just be a very compact system that's easy to carry and deploy. But of course, in the future, a blended wing body design, we could actually increase our endurance and range with an order of magnitude.
Yeah, and then just the other question is engine out performance. I assume engine out is a pretty dangerous situation for you guys.
Absolutely, absolutely. So this is kind of like the starting point for us, but in the future, the way this vehicle works is that there's actually additional room above and below each engine. So each corner, we've hoped to have 2 to 3 microturbines. So then you're looking at a 8 or a 12 engine vehicle. So then in that case, if one of the engines or even 2 of the engines fails, it's not a big deal. You can still continue and fly the mission.
Sure. Well, thank you, Alex. Really appreciate you coming on. Very interesting concept, and congratulations from us on getting it flying. That's always a big step. So
thank you. Thank you very much.
So we're going to switch over now to Mr. Michael LaCourie, CEO and founder of Aereo. Michael, did you want me to share your slides for you, or?
Actually, can we skip me? Well, wait a second here. I might be able to.
Yeah, no problem. If we want to.
It's been churning on trying to connect to Zoom here for like the last 15 minutes, and I don't know why I can't connect in. So maybe skip me, come back, because I don't think you have the current version of my PowerPoint. I just discovered that.
Okay, yeah, we'll skip you. We'll catch you at the end. So,
okay,
Mike,
thanks.
Mike, if you're ready, we're going to switch over to you, Mr. Mike Bartlett, the founder and president of American Aerospace Engineering.
Certainly.
Mike, just turn on your camera there as well. Thank you, sir.
Oh. And share. Oops. I want to get my camera on. Oh, geez, there my camera is on. All can see me?
Yeah, perfect. If you could just go to full screen. Perfect.
Full screen. And how's that?
Off to the races, sir. Over to you.
Thank you. Thanks, Sterling. And thank you for the invite. I really appreciate it. I'm Mike Bartlett, as you said, president and founder of American Aerospace Engineering. And as you see, we're in the business of designing, developing, building full systems, a system of systems, VTOL aircraft, predominantly tandem tilt wings. And we've been doing this for quite some time. You'll see the image on the top right-hand corner. Is it in the VTOL mode? So it's a VTOL with fixed wing performance. And then the three lower pictures, you'll see the aircraft flying normal mode. And then it also has, the current version has a 14-foot by 6-foot payload bay, carries over 1,000 pounds, and it can be autonomously jettisoned, or it can land and release the payload bay. It can fly with and without the payload bay as well. I don't know if you all can hear me well. I'll carry on.
Yeah, sounds great.
Good. My background, I've been around a while. There's my email address, the website for American Aerospace Engineering, and AAE was founded in 2008. As I said, I'm the founder, sole owner, chief engineer. I've got 40 years of aerospace engineering experience with 23 years of FAA flight test. I'm a fixed wing, rotor wing pilot, FAA certified, instrument rated pilot. Was a captain in the Air Force. I graduated from National Test Pilot School a few years back. I've been designing, developing UAVs for over 14 years now. And two of the well-known ones are Scan Eagle and Blackjack. I helped with all the continuous improvement of Scan Eagle and helped in the initial flight testing of the Blackjack and then getting that into a STUAS program. Okay. Just as our progression, as I said, in 2008, you'll see the top figure up there on the left-hand side is our proof of concept. There's a 40-foot wingspan, internal combustion engines, and you can see the sheer size of that by the size of the folks standing next to it with the wings tilted. The picture below that you'll see is of the vehicle without a payload bay, and then just various other images of vehicles that we have. As I mentioned, AE helped develop Scan Eagle and helped with the Blackjack for Boeing in situ. And over the years, AE has developed more than 8 UAVs for Department of Defense. And we're currently, as I said, working with Air Force Agility Prime. Very proud of that we're part of the team. It's awesome. Thank you very much. And this is our third virtual trade show or meeting or discussion, so thank you. We were currently awarded a U.S. Air Force SPR contract, a phase 1, which we're almost completing. And then we're submitting, the Air Force asked us to submit for a phase 2. And I can talk a little bit more in detail about that. So the AE Eversaw family of products, they're fully scalable, and we do address all the groups of UAVs. It's the same vehicle, just scaled. The group 1 from 0 to up to 20 pounds, group 2 up to 55 pounds, group 3 larger up to 1,300 pounds, and then group 4 over 1,300 pounds. So we've done UAVs from, well, 5-pound UAVs, and I've designed UAVs up to 20,000 pounds. So we've covered the full range. And we don't just do the aero performance we do the material, the composites, we do the avionics systems, the software, propulsion systems, ground control stations. We're a one-stop shop. What's unique about this vehicle is that large payload bay is detachable. It's also designed as a lifting body. You could see that quite quickly. So it does, we've done extensive CFD work on this vehicle, and the payload bay generates over 30% of the overall lift. And also we're not dedicated to that shape of the payload bay. So we envision that a custom would have a family of payload bays dedicated for various missions. And also what's kind of neat about this vehicle is the payload bay can move back and forth. So it has variable stability in the sense that if you're coming in for an approach, you would want to be in a forward CG for a more stable aircraft. If you're on a long range flight, you go a little bit to an AFCG to reduce trim drag. And coming into the hover, obviously you want it in a mid CG, and this is all done via the autopilot. And as I mentioned, our mission right now was for the US Air Force SBIR award. The award was for an unmanned aerial system aircraft rescue and firefighting program. For the phase one, we're doing a flight demonstration with our 360-pound vehicle, showing that we can douse out a fuel spill fire about 3-foot diameter in the hover. And we are demonstrating 2 fire retardant techniques. We are using a sky cannon coupled with an infrared camera, and then we will disperse the fire retardant with a pinpoint accuracy. We're also using a second method, which is the air attack method of just flying over the fire and just dumping the fire retardant on the fire. Yeah, so we received the SBR for the 360-pound vehicle. The basis of the phase 2 proposal was that the Air Force were looking for a UAV that could be stationed at their Air Force bases. And then if an aircraft takes off and gets in distress, or aircraft's coming in distress and has to do a forced landing out of the perimeter of the Air Force base, maybe rocky terrain or forested terrain, this vehicle would take off, fly to that area. It could dispense 2,200 pounds of fire retardant, enough to put out a 50 megawatt fire. And then in the hover, it could basically hoist conscious personnel up onto the aircraft and fly them back. Or they also spoke about hoisting folks down to help get folks out of the crash vehicle. So that's the intent and the mission that the Air Force is looking at for the phase 2 and the phase 3. What is our role in the ecosystem? Obviously, we've been working really hard for the all-electric FAA certified Uber Elevate, Uber Challenge, and we've already designed the 8-seater VTOL. We're also looking, as folks have kind of alluded to, that battery technology is still trying to catch up for endurance and density. So there's a bridging kind of a opportunity for us to use hybrid, and we've done this already. Also FAA certified, as I mentioned, I've got over 23 years of FAA certification. So everything we do is DR 178C. It's all FAA certified with multiple redundant systems. So if you do have an engine out, you're not just going to crash and burn. Also looking at VTOLs, working closely with the US, with the California Fire Department, looking at large UAVs to help put out forest fires and rescue the survivors in the forest. Working with a company that's been around for 60 years called Simplex. That's their job, is doing supplementary type certificates on helicopters to attach these large tanks that carry water tanks to put out fires. And they were looking at high-rise building fires around the world. So you could even use a smaller UAV in between the buildings to pinpoint a fire that's just started and quickly put it out. Also, we're working very hard with the solar-powered market, and we've already implemented solar cells on UAVs, and with the intent that these UAVs fly at high altitude and are powered solely on solar power. And we've made quite large strides in that area. Also, what you mentioned a little earlier on about Sterling, about we partnered with a company. It's a propulsion company that have blowers on the wing, and our concept is a fully blown wing. So we don't have propellers. The wing is air blown, and it has a very low disk loading, meaning obviously it could land in a confined area and it's not going to tear up the surface or get papers and objects flying around. So it's got a low disk loading as well as no moving parts. So it seems to be more efficient than the conventional propeller system. It's far better, more efficient than the jet thrust system. And obviously, not having rotating propellers as they do pose an inherent danger operating near people. Commercial operations, I'm not going to go through everything, but just aerial applications. We have the Sky Cannon for high-rise firefighting, wildland firefighting, oil spills, agricultural spray applications, air-land rescue. That's awesome because the pod we have right now could pick up 4 people very easily. What's exciting with the air-sea rescue operation is that the vehicle can have floats, very little drag penalty on the floats. It could land on the water, open up the ramp, and then the folks could climb into the payload bay and it could take off, or it could fly low and drop off a dinghy for the folks who are at sea who need to be rescued. FedEx has shown interest, and we've been talking to them for about 2 years now. We're sure that UPS would follow suit. Being electric and the solar powered version, we could look at high altitude, low cost satellites. A lot of this could be used for disaster relief, for mobile cell phone towers. It can be treated as a helicopter, so it can cargo sling, loads in and just drop them off. It can hoist, as I said, folks up and down. Cargo drops. It's ideal for logistics resupply. Also, EO, IR, camera, ISR missions. It could have an endurance up to 19 hours. And it's ideal as a first responder for medevac, casevac, whatever the case may be. And so what type of opportunities are we looking for? We're really looking for maybe, as I mentioned, Sterling, we're going into the phase 2. So any support or memo from Agility Prime to give us a better chance at winning the phase 2 through, I know that the US Air Force is working through AFWERX for the funding, and we'd highly appreciate that. As I said, the US Air Force has requested a RAM for a 6,000-pound Eversaw for the phase 2. They've also looked at a couple of the 360-pound vehicles and also looking at the 55-pound vehicles. So, if you want a scalable family of orbs, place an order. We're not looking for money just to hand out. We want an order. Give us an order and we'll deliver. What would be good is if there are folks interested, you could facilitate meetings with potential customers and investors if need be. We understand the US Air Force requirements for a program of record, And you did mention that you could get test ranges and certification support, which we would really appreciate. And I think that's my last slide.
Yeah, for sure. Thanks, Mike. That was great. A few questions from the audience here.
Certainly.
I know one person was asking just a little bit on the trade-offs between tilt wing and kind of split thrust and lift fans. I know that a lot of complications come with tilt wings, but you get some advantages in terms of performance. Can you just speak a little bit on where you guys fit in that trade space and why you decided to go with tilt wing?
Yes, certainly. Typically, if your aircraft weighs 20,000 pounds, you need about 10,000 pounds of thrust to get you going down the runway to get takeoff, right? You need airspeed. This vehicle, we simulate that with the fully blown wing. So as soon as the propellers turn or whatever propulsion system we're using, as soon as that airflow flows over the wing at a certain velocity, those wings are creating lift. And so what we do is we could get ourselves airborne with 10 to 15 degrees angle of attack. So yeah, so we've got a very elegant takeoff and landing procedure. So yeah, so we're
sure, it's definitely a very interesting design there.
Yeah, and so what happens is because of my years and years of flying, the transition part of it is always very risky. And typically with helicopters, you do see a large power demand as you go through transition, or as you go through ground effect, whatever the case may be. So we've kept that transition very short, within seconds. And at the type of landing, you would see this aircraft would just fly in, tilt the wing 15 degrees, flare, and touchdown.
Yeah, no, that's very interesting. Excited to see you guys flying your prototype, and we'll chat up on email after this on some of your civil work. So love to catch up on that. Thanks for coming on, Mike.
Appreciate that. Thanks, Dilly.
Now we're going to switch over to Michael LeCory, the CEO and co-founder of Aereo. Michael?
Great, thanks. Can you hear me?
Yeah, we got you, sir.
Okay. Now the tricky part is I'm going to have to run audio through one device and the screen share through another. So hopefully that doesn't screw us up too much. And let's see. Can you see my screen?
Yeah, we got you, sir. Over to you.
You got my audio?
Yes,
Touchdown. Wow, this was quite a challenge to get the technology to work here. I've got 4 different machines here, and I got 2 of them combined to work great. So thank you for your patience, folks. My name is Michael LeCory. I'm CEO of Aereo, and we are a brand new company. As a matter of fact, we're still in the process of getting formally incorporated, but we've been operating for the last 2 years or so, kind of in R&D mode. We are focusing specifically on flight path automation and how do we design the flight paths for these automated systems. Now, why is it not advanced? There we go. So who should control the flight path planning process in an automated environment? That's kind of the core question we're asking. And I'd say that we don't really have an answer to that yet at a ecosystem level. Obviously, we have pilots who control it. If it's a piloted vehicle, there's some question about UTM and detect and avoid as we move forward. So we see kind of 4 core elements that really drive the vehicle automation, the flight path automation. One is obviously the unmanned traffic management systems that are being developed. These are primarily regulatory. They tend to be constraint-based. They tend to focus less on the mission and more on conflict avoidance, which is a good thing. But if you're mission focused, the UTM is probably not going to be your best friend. Detect and avoid systems are great. They're necessary, but they're kind of last minute emergency kinds of things. They're really hard to integrate into a planning process. If you're trying to predict a specific arrival time, for example, and depending on detect and avoid systems, their ability to arrive on time is quite limited. Matter of fact, according to some research from NASA, with as few as 5 vehicles per square kilometer, you are guaranteed to have some conflict avoidance maneuvers required. The other is the autopilot and navigation systems that exist on the vehicle itself. There's some different technologies that are available right now, and some limitations, especially with the drone space, in terms of the accuracy and reliability of those systems in terms of positioning and things like that. And then finally, what we're specializing in is the flight path management systems. And we think this is where some of the greatest opportunity to improve some of the conflict avoidance and mission accuracy resides. And I'll share how we're going to do that with you. Specifically, the manual flight planning process is currently fairly cumbersome for both UAVs and UAM operators. And in order to fly a mission, typically takes anywhere from 2 to 4 hours of prep work, developing mission specifications, reviewing complicated regulations, pulling up any geospatial maps that may be required, integrating with traffic management, coordinating with others, developing waypoint navigation, importing and exporting files across systems. We find that in the drone world, the average operator can spend about 3 to 4 hours on these pre-flight planning elements. We think we can get that down to about 5 minutes. The way that we do that is through something we call a resilient flight path. This is a flight path that's both robust, safe, and stable while operating in shared space that is highly dynamic. We've identified 9 essential criteria for resilient flight paths. I won't spend a lot of time going into these, but they focus on mission objectives, defining the navigational space. So that's using digital twin technologies, for example, in the urban environments, developing several kinds of flight path deconfliction, as well as midair detect and avoid deconfliction, making sure that we're compliant with all the regulatory requirements, the ability to execute the flight path in real time, which requires the ability to transfer that flight path information from the cloud, which is where we're doing the flight path planning, into the vehicle itself, and then being able to have that vehicle execute that flight path precisely. I'll share with you how we plan on doing that. The ability to manage simultaneous flight paths. We can do currently as many as 350 vehicles per square kilometer, which is an insanely large number, but we're really trying to push the boundaries of our technology. Obviously, it's got to have certain management functions that allow operators to manage multiple vehicles at once, and we're relying a lot on machine learning and artificial intelligence to do that. So the flight path automation system that we're developing, we have 4 core innovations that we're bringing to the current system. One is we have a new flight path creation algorithms. This allows us to deconflict the flight path in the process of constructing the automated flight path itself. So, so it allows us to manage multiple vehicles operating in the same space, trying to navigate around each other, but without actually imposing any conflicts. We have a new approach to flight trajectories. This is, we're using what we call a multi-dimensional approach. So we take, we actually add more dimensions. I think we're at 5 or 6 different dimensions right now in order to handle the 3-dimensional space plus time. Plus we also have additional dimensions that help with the deconfliction. We have a new approach to autopilot integration. This is a continuous path regulator that allows us to take and update precise positioning information on a microsecond level to allow the vehicle to stay on a continuous path. Instead of just hitting waypoints, we can actually follow a very precise line, or tube, as the case may be. And then finally, we're developing some automated mission planning capabilities that that use geospatial information to help the vehicle make its own decisions about where to fly and how to fly. So this is an example of one of our simulations. This was downtown San Francisco. That big tall building kind of in the middle there is the Salesforce Tower. It's about 1,000 feet, which is well above the 500-foot floor for the low altitude drone space. Each of these, we basically ran a simulation with 350 vehicles operating in a 1 square kilometer section of San Francisco, and we were able to successfully deconflict all 350 of those flights. The way that we do that is we've got 5 core components. There's a navigational space model, which defines the operational space in the environment. There's a pathfinding and auto routing section. This is where we take auto routing technology, mathematics that have been developed since about the 1950s that allow us to take multiple traces and ensure that they each have a unique path. We use cost function optimization in order to make sure there's solid alignment with the mission. We use detect and avoid integration strategies to allow us to avoid any unplanned mid-air conflicts. And then we have the continuous path regulator that translates that information into the vehicle. So this is a simulation that we have of a number of vehicles in a vertiport configuration flying out of the ferry building in San Francisco. And you can see that it effectively sends each of those different vehicles off on its own path without forming any conflicts. In addition to that, we can align the pathways so that when multiple vehicles are headed in the same direction, they can converge into a what we call a virtual highway that is a temporary reserved space in the airspace that allows vehicles to migrate as the traffic demand requires, but also allows for a safer transportation of all those vehicles operating in the same direction. So the system that we've got in development here allows for multi-vehicle path search and optimization. It allows for mission scheduling, so we can schedule out and plan for multiple vehicles operating over a period of time. We're planning on using automated UTM authorization systems through API calls, etc. We have the integrated navigation and tracking and reporting functions. We're developing partnerships with a number of different organizations right now. I won't go into the detail on all these partnerships, but they are each quite unique and interesting, and I'm happy to share some of those with you. We've got 6 patents that we have access to, 2 of which are our own that were developed in 2019, and then we have 4 others that my co-founder David developed back in 2016 under a different company, and that company right now is just a shell company that owns the patents. So we've made an arrangement with them to further develop and commercialize those patents as well. So our invitation is to come play with us. We're, like I said, we're just getting started. We're pre-funding, pre-sales, pre-everything. We're looking for test projects. We'd like to be able to bring some of these simulations out of the simulated space into the real world. So we're looking for some projects that we can help do that with. We're looking for partners and data providers, especially on the geospatial side. Obviously looking for funding, just starting our seed funding campaign to raise some seed capital. We're looking to hire a couple of expert team members if you know anybody who's interested in what we're doing. Always open to having conversations. There's so much happening in the space right now. I think the more that we can align our capabilities, the better we'll be as an ecosystem. And then, of course, we'll excited to have any kind of moral support. So with that, open up to any questions. If you want to reach out to me, my phone number, my cell phone number is listed there, as well as my email address, and you can reach out.
Yeah, for sure. Thanks, Michael. That's really great. Really interesting to see your simulations there. I was just immediately came into mind. Can you kind of program the cloud of avoidance around buildings to different distances, or?
Absolutely, yeah. Right now, the model that we ran for downtown San Francisco, we initially had a 10-meter buffer around all the buildings. Found that didn't quite get us enough in some cases because some of the buildings are not shaped the same. You know, their footprint and their sky print look a little different. So so we can actually adapt different buffers for different size buildings. The other thing, one of the things I didn't share was one of the dimensional elements that we brought into the flight path planning is the ability to build a bubble around each of the vehicles. It's what we call an avoidance limit. And we can we can have those bubbles be anywhere from 10 meters to 100 meters, or even 1,000 meters if we wanted to. And what those bubbles end up doing is converting the flight paths from a path into a tube that can increase the amount of protection area around a particular vehicle. So if it's, let's say if we're flying a drone package, there might not be as much need to protect that vehicle as would, let's say, a UAM vehicle that had 8 occupants. So we could certainly adjust not only to the size of the vehicle, but to the sensitivity of the payload.
Yeah, for sure. And then I guess from your comment, you guys are just using kind of ground footprint and height. Do you guys intend to go to like full LiDAR scan 3D images of downtown areas, or how do you expect to ingest data that way?
Yeah, what we envision, and this is one of the things that we're still kind of wrestling with, is how do we inform the kind of navigational space model? There's a couple of ways to do that. Obviously, there's LiDAR, there's real-time visual processing. The challenge with those kinds of things is they all require an incredible amount of onboard data processing, and that translates to bandwidth limitations. So ideally, we'd like to create these virtual, what we call digital twins of the landscape that are precise enough and updated frequently enough that they can live in the cloud, so that that information is accessible instantly. And then I think one of the other presenters was showing that, modifying the amount of bandwidth that you bring back into the cloud so that you're not overloading it with useless information, but only bringing in the real-time information that you need in order to make adjustments. That's going to be, I think, the cutting edge of where the next generation of technology needs to be.
Yeah, for sure. Very interesting. I think there might end up being a commercial space just for the folks who create the geospatial mapping, and then the folks doing UTM and flight path planning is a separate entity. So very interesting stuff there. And I think there's actually a whole group of questions for you in the Q&A feature if you want to address them in chat. But we're going to switch over to our last speaker. So thanks for coming on, Michael.
You bet.
And finally, last but not least, we got Sean coming on. Sean Wilson is Director and Air Force Innovation for American Data Solutions, Inc. Sean, over to you.
Hi, Sterling. Thank you very much. I appreciate it. Thanks for saving the best for last, obviously. I appreciate all the previous speakers getting to do all the cool, bright, shiny stuff. And I'm going to talk about the NUG work, the data, and the logistics. And thanks, a big shout out to Mike Bartlett for actually mentioning logistics one time. When we start building all these really cool things, people often forget about the logistics and laying in the capabilities that we need as far as supply chain management, posturing spares, and making sure that the technicians have what they need. The one thing we know, and I'll tell you a little bit about me, I spent 26 years in the Air Force working aircraft maintenance and logistics, quality control, production, operations, fleet management, supply chain management. The last part of my career was developing the sustainment strategy for the Air Force, working with a smart team there in the Pentagon, and implementing predictive maintenance solutions. In the Air Force, we call it CBM Plus, and one of the primary focuses of that was automated data collection. Because when I started seeing the Agility Prime project and all the cool stuff, I started thinking, you know what, we need data. If all the smart people that talked before me, they need data, and they need that data managed properly. And ADS, we at ADS, and our flagship product, NVDV, multipurpose digital data viewer, has solved a bunch of the issues that we'll have in Agility Prime, as well as any other aviation project. So what is NVDV? We'll start off, it's a hub of logistics. It's a web application, a suite of tools where we combine super interactive technical manuals, and we're able to simultaneously and interchangeably support all the platforms and all data types, whether it's in XML, HTML, PDF, whatever, with zero footprint. We host them all in the cloud. We're in AWS GovCloud right now. Obviously, Azure is available to us as well if we need to. We host a common source database, so all of your technical data that you have in the development of all your projects, we're able to host all of that. We're working on now virtual maintenance logbooks. So in the Air Force and the other services, they're still using paper logbooks. In the commercial industry, they're still using a lot of paper logbooks. We're virtualizing that, and we're automating the data collection, and that's key. So in my experience in maintenance, there's a lot of big problems. There's too much paperwork. Then you tell a technician after a long day of fixing whatever the aerial vehicle is, hey, now I need you to go in and put correct data into the system at the end of the day. And they're stuck in that system and the constructs of that system. What that means is they're going to make the bad screen go away, whatever they have to do. And so the data that you might be collecting it could be bad. And then you're making decisions on that. And so here's where the data collection and the logistics command and control nature of MDDV is so important and can help you, all of you out. We talk about a practice like you play training area, fleet management dashboard, business intelligence tools that are pulled directly from the technical data, the maintenance data that you have. It's key. It's game-changing technology that will allow you to make really good decisions as far as your spares posturing, as far as making sure that your supply chain is where it needs to be. And the really cool thing, and kind of my baby in all this, is the 100% secure social network that we're developing. In all my years, in 26 years of fixing airplanes, I saw aircraft maintainers inside the Air Force use Facebook Messenger, Instagram, other social media avenues to potentially talk about classified information. So, you know, it's critical that you are able to do file sharing and connect maintainers, aircraft technicians with engineers and all the other smart people and supply chain managers. Shrink that globe a little bit and take advantage of that technology. What are we doing in the Air Force right now? So we're on contract with NQ9. So obviously we have UAV experience. We're in a sustainment contract now, managing all of their ground control station, flight, ground control system, flight and maintenance publications inside of MDDB right now. We also are working with the HH60 and we're hoping to be online with them by next year. And we are on contract with Northrop Grumman in development of the new bomber. Obviously, we've been around for a little bit longer than some of you guys as far as a business entity is concerned. But we're still small business, American-owned, led by Air Force veterans and some of the best programmers on the planet. How is it different than your normal just interactive technical manual or your normal tech publication? Well, it's powered by the technology, the Windows technology. It's used in 91 of the Fortune 100 companies. It's able to optimize data sets and make it fully interactive. And the security features are second to none. We are actually the only certified, CIPRNet certified data management service around today. And you know, we're fast. We use zero weight state tech design. So it's not big and bulky as far as your data is concerned. And we're able to use it with zero footprint. And the biggest thing, what most people like, what our technicians are really liking, is that it's intuitive and it's customizable. Whatever you need it to look like, it's easy for us to adjust. MDDV is disruptive. So here's the thing: it automates what needs to be automated and gets your technicians and your operators, your pilots, and all the people that are involved in your operation. It gets them back to doing what they're trained to do instead of trying to worry about data. Right? We're able to automate all the manual paperwork and the data collection that's critical. We're able to automate supply transactions and all your fleet management requirements. And that enables predictive maintenance solutions to be developed for your preventative maintenance and your predictive maintenance schedules and forecasting, which I'll tell you is a huge deal from the technician side of the house. We're able to support any data type, any data format. Like I said, it's fully customizable. And our development is very agile, and we're pretty proud of that because we have domain experts like myself and all the other members of our team we work hand in hand with our programmers, and we're able to make sure that the UX, the user experience, is second to none, and we're able to make changes and updates on a truly agile manner. So a couple of other tools, and I'll skip through some of the stuff, but we'll talk about MDD Livewire as far as wiring diagrams are concerned. It's the best on the market. It's the most intuitive, and it's the highest the most integrated. It can be integrated with your supply chain systems as well. And you look at that quote, and this is from a friend of mine who had been working on F-16s for 22 years. He saw the presentation, and he saw how fast we were able to do research to find the pin and a cannon plug that we needed, and how fast we could do it. And every maintainer that's seen it has been blown away, including myself, which is why I'm here. Another thing is, one of the biggest things I hated about moving around the Air Force is learning new data systems. Well, this one, like I said, is completely intuitive, and it takes minutes to learn. You don't have to teach a 3-year-old how to work an iPad when you hand it to them. You just hand it to them and they know how to work it. Well, that's what our products do. A little bit, more of this. Again, we talked about the security. It's completely operating system and hardware agnostic. It works on anything. It's modular and customizable. We have lots of products and tools. Like we said, our flagship product is MDDV, is the technical publication viewer. However, it works with all these different modular software packages that we can put together. We talked a little bit about CBM Plus, and I don't know if you guys are familiar with that, but it's the Air Force's solution for predictive maintenance. And it's implementing it. And that's one of the last things that I was doing, was working on that implementation while I was on active duty. Maintenance data collection, though, is crucial. What we found as we were trying to do all the analysis of all the data that we had, and we had obviously tons and tons of data after flying airplanes for decades, is that the data was often bad. And it was not necessarily at the fault of the technician that was inputting it. It was the methodology for which we were collecting data was flawed. So here's what we know. Flying cars will break, right? Orbs will break. They're still mechanical. And so you need to be able to collect that data from the ground up and make good decisions moving forward from there. So I believe it's a good opportunity to take the lessons learned from years and years of flying aircraft or driving boats, driving cars, and make sure that we lay in the eVTOL, the Orb, the flying car program the right way. We had the University of Dayton Research Institute took one little process from the C5 Galaxy, from their minor ISOs and home station checks, and they determined in their cost benefit analysis that if using MDDV, they would be able to save 20 to 30% on all maintenance actions. So what does that mean? I believe the biggest thing is the banner at the bottom that says their quote, using MDDV will save the C5 program $34 million a year. Now, that might not seem like a lot, but when you're talking about this is just the isochronal inspection and home station check process, and if you scale that across every platform and across all flight line and hangar maintenance actions, I believe we're kind of lowballing the estimate here with $700 million annually. It could be greater than that. So, and as you know, I mentioned before, I'm an Air Force airman. So you'll see that the presentation is largely Air Force centric, but the software is customizable. And I like to say that if you have anything that requires technical manuals and is resource managed, we can solve your problems for you. We talked about a little bit about the advanced technology. Our CEO, Ron Mraz, who started off as an aircraft maintainer, has over 100 patents for all the software solutions and the data management tools that we offer today. So we talked a little bit about the virtual maintenance logbooks. I think this is key. It's insane. I would watch technicians with their paper logbooks, they would have to fill out what a discrepancy is in the corrective action, and then they would have to pick up their personal cell phones and call a maintenance operations center to enter a discrepancy into a system, and then the maintainer would have to go into the system and close out and input what the corrective action was. It's ridiculous that all those steps are required, and it's largely policy. We're not going to have that problem in the Agility Prime world if we start off initially automating and virtualizing all those requirements. Data is critical. It's important. It's important for decision support down the road, and so we should make sure we do it right. Supply chain management, we talked about that. We can automate and virtualize any supply transaction as long as we have an authority to operate inside a system. And we talked a little bit about the social network. Like I said, this is my baby, but most of the young technicians that are going to be working on your vehicles, they grew up in the virtual age with iPads in their hands. They're used to doing that, and they're all on social media. So let's provide them a 100% secure social network that they can operate in. Here's a summary. Again, get rid of paperwork, save airman time, and that 50% mark estimate is really accurate. And I'll tell you, as an aircraft maintainer, we spend way too much time doing paperwork instead of fixing airplanes, and so we don't want to have that problem in the Agility Prime ecosystem. Here's our contact information. My CEO and my executive vice president, our emails are there, but you'll see my name, csean.wilson@ndbb.com. And if you have any questions, shoot me a chat right now, and I'll give you the rest of my contact information. Thank you.
Yeah, thanks, Sean. That was a really great presentation. I really appreciate you guys coming on, and really everyone coming on today. Great speakers today. I know we ran a little bit long there. I didn't want to cut you off, Sean, but appreciate everyone coming on, and we'll see you next week. Remember, guys, next week the webinar will be on Wednesday afternoon, not Friday, with the special speakers from the Air Force, FAA, NASA on simplified vehicle operations. So should be a very good one, hosted by Mr. Frank Delsing from our team. So thank you, everyone, for today, and look forward to seeing you next week. Everyone have a nice weekend.
Thanks, Danny.
Thanks a lot.
Thanks a lot, guys. Appreciate it. Thanks, Sterling.